In this video, I will show you how to find the slope of the tangent line of an implicitly defined function, which, remember, that just means that y is not by itself. So we have to use implicit differentiation. I like to spread out the equation a little bit because we're going to need to take the derivative of each term separately. So I'm going to need room for my ddx's. So we're going to take the derivative of both sides of this equation, which in practice means we're going to wind up taking the derivative of each term. And I'm going to show that just by putting a ddx in front of everything. All right, so when the variables match, we're doing ddx, and this is an x variable. When that happens, we get to just do what we normally do and use the power rule. So I'm going to wind up with 2x. But when we get to a term where the variables don't match, this is ddx, but yet we have a y, we're going to actually have to use the chain rule. So we're going to take the derivative, but this is considered the outer function. So we're going to wind up, yes, doing the power rule, and we will have 2 times 4, which is going to give us 8. And then we decrease the power by 1, so we just have 8y. But that was the outer function. Because this is not an x, we have to treat this as an inner function, and we have to take the derivative of the inner function right now. So the derivative of y will simply be dy dx. All right, now the derivative of a constant is simply 0. Of course, dy dx, this is what we're trying to solve for. If we can get this by itself, that will be the derivative of y with respect to x. So let's just algebraically isolate this. If we subtract 2x from both sides, then we have 8y times dy dx is equal to negative 2x. Now, if we divide both sides by 8y to get dy dx by itself, then we will have dy dx is equal to negative 2x over 8y. Let's go ahead and simplify this a little bit. So I'll have dy dx equals negative, and 2 over 8 reduces down to 1 over 4. So this will be negative x over 4y. And that's it. This is the derivative. So that means this is a little formula that tells me the slope of the curve at any xy pair. We are being asked to find the slope at the point square root of 2 comma negative 1 over square root of 2. So let's go ahead and use the formula that we just found. So the slope, y prime, should equal negative, and x is the square root of 2, so I'll put that in for x, and then we have 4 times the y value, which is negative 1 over the square root of 2. So it's really just a matter of simplifying this, and let's see, maybe I'll just continue here. First of all, this negative is going to end up out in the front, and it's going to cancel out this negative. So whatever else happens, it's going to be a positive result. So in the numerator, we will still have the radical 2 for now. If I treat this 4 like 4 over 1, and just multiply straight across with this fraction, it's pretty clear that I'm just going to have 4 over radical 2. So when we divide by a fraction, we multiply by the reciprocal. So this is going to be the same thing as radical 2 times, and then the reciprocal here would be radical 2 over 4. Interesting. Well, again, I'm going to just put a little 1 under here to make it more obvious that I'm just multiplying straight across. And we know that radical 2 times radical 2 is just a regular 2. And so that's going to be 2 over 4, which simplifies down to 1/2. So this should be the slope of the curve at this particular point. Let's take a look at that graphically. So this ellipse is the graph of x squared plus 4y squared equals 4. And here is the point radical 2 comma negative 1 over radical 2. And here is the tangent line at that point, which does have a slope of 1/2. Example 2, determine the slope of the graph of 3 times the quantity x squared plus y squared squared equals 100 xy at the point 3 comma 1. So this problem looks like a lot of fun. Right at the beginning, I see that we have a function inside of a function, and so that's going to be a chain rule happening. So let's get started. We're going to need to take the derivative of both sides of the equation. So I'm going to start off with a d dx as I take the derivative of this side of the equation, which is 3 times x squared plus y squared squared. And then we're going to take the derivative of the right-hand side of the equation as well. Now, when you take the derivative of something that has a constant in front of it, you can really just put the constant in front. So I'm just going to take this 3 and put it out in the front. And similarly, I'm going to take this 100 and put it in the front. All right, now let's go ahead and take the derivative of this part right here. So we're definitely going to have to do the chain rule. So we will start by taking the derivative of the outer function. So we're going to have 2 times the quantity, and then this reduces by 1. So right there, I've taken the derivative of the outer function. So right now, the inner function is going to remain the same. So I'm going to leave the inner function as this x squared plus y squared. But now we have to take the derivative of the inner function because that's how the chain rule works. So now as I take the derivative of the inner function, that's going to be, all right, d dx of x squared plus y squared. All right, don't forget we have this 3 waiting for us out in the front of this entire thing. Okay, see that 3 right there? There's my 3. Okay, so I think I'll go forward and work on the right-hand side of this equation a little bit for now. So here's my 100. That's going to be waiting patiently for me. But I need to take the derivative of x times y. So this is a product. So I'm going to have to do the product rule right now. So let's remember how the product rule works is that we wind up taking the derivative of each one in turn. So we're going to wind up doing the derivative of x times y. So the derivative of x is just 1, so basically nothing, and then times y, and then we'll do plus, and then this time around we leave x alone, and we do the derivative of y. So that will be dy dx. All right, do you understand? Do you follow what's happening here? I'm doing the derivative of x, and then I'm leaving y alone, and then I'm leaving x alone, and then I'm doing the derivative of y. Okay, so that's what happened. All right, I think I'll continue working on the left-hand side of this equation for a while. Let's keep following the d dx part. So if I want to take the derivative of x squared plus y squared, I can simply take the derivative of each part right here. So the derivative of x squared is going to be 2x. All right, so boom, I did the derivative of x squared. Now the derivative of y squared, because the variables don't match, I have to do the chain rule. So I'm going to do the derivative of the outer function, so that's going to make this into 2y. But then I have to do times the derivative of the inner function. In other words, times dy dx. Okay, so I have all of this being multiplied by this. I might as well go ahead and do the distributive property here with the 2. So that's going to give us 2x squared plus 2y squared. All right, and I still have this 3 out in front. Don't forget about that. All right, what's going on with the right-hand side of the equation? Let's check that out some more. Well, I guess I could just distribute this 100. So that's going to give us 100y plus x times dy, well, plus 100, sorry. 100x dy dx. All right, somehow we need to solve this for dy dx, but I need to get rid of all these parentheses and things, so I'm going to have to multiply this out. This is going to be sort of a double distributive property that's about to happen between this binomial and this binomial. Okay, so brace for that. I'm going to have this 3. I'm going to just keep that way out front. So what's happening is I'm going to do 2x squared times everything right now. So 2x squared times 2x is going to give me 4x to the third power. And then 2x squared times 2y dy dx is going to give me 4x squared y, and of course I'm going to have my dy dx. Okay, now I'm going to distribute the 2y squared like this. So I'm going to have 2y squared times 2x, and that's going to be 4xy squared. And then 2y squared times 2y is going to give me 4y to the third power. And don't forget your dy dx. Okay. Let's go ahead and just bring down the right-hand side of the equation, which is 100y plus 100x dy dx. All right, let's just distribute the 3 throughout everything. So that's going to give us 12x to the third power plus 12 x squared y dy dx plus 12 xy squared plus 12 y to the third power dy dx. Okay, in order to solve this for dy dx, we need to get all of the terms that have dy dx in it on the left side of the equation, and all of the terms that don't need to end up on the right-hand side of the equation. So count these dy dx's. I have 1, 2, 3. They all need to end up on the left. Okay, so here comes the first one. All right, these two are already on the left, so I'm just going to scooch them over to make room. So I'm going to have 12 x squared y dy dx. And then here comes the 12 y to the third power dy dx. Okay, now here comes this one though. I'm subtracting it from both sides, so I'm going to have minus 100x dy dx. Okay, now what needs to get moved over to the other side? Well, here we have this 12x to the third power. That has no dy dx, and we have this 12xy squared, which does not have a dy dx. These two need to get moved to the right-hand side of the equation. Okay, so I already have 100y, which is going to stay on the right-hand side. But now I'm going to have minus 12x to the third power and minus 12xy squared. Okay, so everything with the dy dx is now on the left-hand side. The beauty of that is that I can factor the dy dx out as a GCF. So I can put dy dx out in the very front of this entire thing. And that's just going to leave 12x squared y plus 12y to the third power minus 100x. I guess I can tighten this up a little bit. Is equal to all of this, 100y minus 12x to the third power minus 12xy squared. All right. So finally, I've boiled it down to a single dy dx, so I can divide both sides of the equation by this entire factor. So this is going to just basically end up in the denominator right here. So what you end up is this monstrosity. We can simplify this a tiny bit if we notice that every single coefficient here is divisible by 4. So, you can think of it as dividing the numerator and denominator by 4. Or you can think of it as taking out a GCF of 4. Maybe that's the best way to think about it. So we could have dy dx equals, and if we take out a GCF of 4, then that's going to leave behind 25y minus 3x to the third power minus 3xy squared. And then if I take out another GCF of 4, then that's going to be 3x squared y plus 3y to the third power minus 25 x. And of course, these 4's will cancel each other out. All right, so basically here is what you will have. And I think I'll just erase this. So here is your more simplified version of the slope of the curve at any point x comma y. So remember, we are supposed to find the slope at the point 3 comma 1. So that really just means substitute 3 and 1 for all the x's and y's in this equation. So that will look like this. Here I've substituted 1 for all of the y's and 3 for all of the x's. And it's just a matter of simplifying this down. I accidentally put a 1 right here. It should have been a 3. Anyway, so that simplifies down to this, which simplifies down to this, which equals 13 over 9. So this is the slope of the curve at this point. Let's take a look at this graphically. So first of all, this is the graph of the equation 3 times x squared plus y squared squared equals 100xy. What a fun looking little graph. And here is the point 3 comma 1. And so you see I've set up the equation of the line through that point that has the slope 13 over 9. If you look over here on the left, the bottom equation, and as I turn that on, we see that this is the tangent line at the point 3 comma 1. So the slope is in fact 13 over 9.